Okay, this is lesson 10.4, part 2. And we're looking at ellipses with a center at HK. So please take note of the equation of an ellipse here. This has center at HK, and this one has the horizontal major axis. This one, center at HK, the vertical major axis. So for the first example, it's asking us to write an equation of an ellipse that has a center at 0, -3, a horizontal minor axis 4 units long. One of the equation of an. So first it has the center at 0, -3. So I'll just graph that center. Okay, and it has a horizontal minor axis 4 units long. So horizontal minor axis 4 units long. That'll make it 2 units long on each side of center. So I'll count over 2, 1, 2, one at a time. And 1, 2. And a vertical major axis 8 units long. So vertical major axis 8 units long, that means 4 units above center and 4 units below center. 1, 2, 3, 4. 1, 2, 3, 4. Alright, I'm just going to sketch that out. Okay, so let's look at what I know. Since my major axis is vertical, I'll be using this equation of an ellipse. So why don't I just write out the equation for now. So that's x minus h squared over b squared plus y minus k squared over a squared equals 1. Alright, so since my center is at 0, -3, that is my HK. So I have x minus 0 squared, and my b is 1, 2, 2 units, so 2 squared. Y minus k, y minus -3, y plus 3 squared, and then my a is 1, 2, 3, 4. A is 4. And just remember, a is distance from center to vertex, and b is distance from center to co-vertex. So if I clean this up a little, oh, and it's always equal to 1. But clean this up a little bit. X minus 0 is just x. So I'll have x squared over 4 plus y plus 3 squared over 16 equals 1. And that is the equation of this ellipse. Okay, for number 2, it says write an equation of an ellipse with endpoints of major axis 1, 0 and 1, 4, and endpoints of minor axis 0, 2 and 2, 2. Okay, so to start with the problem and just make sense of it, I'll start sketching what it gives me. So endpoints of my major axis are at 1, 0 and 1, 4. Okay, so now I know that I have a vertical major axis. Okay, the endpoints of my minor axis are at 0, 2, and 2, 2. 1, 2, 1, 2. Okay, so from this, I can see exactly where my center is. If you ever can't tell exactly where your center is, you just use the midpoint formula. So I can use the midpoint formula for these two or for these two. In this case, I think it's pretty clear. Our center is right here. Alright, so now I'm going to sketch out my ellipse. And I'll start with my center. So my center is at 1, 1, 2. My center is at 1, 2. Okay, and now I'm gonna use one of my standard forms and just write it out. So why don't I start by saying that A, which is the distance again from center to vertex, is 2, and B, distance from center to co-vertex, is 1. So now I have, and I'm starting with Y this time because my major axis is vertical. So I have Y minus 2 squared over 4, 2 squared here, plus X minus 1 squared and then over B squared, which is over 1 squared. So for now I'm just going to write this over 1. That equals 1. Now when I was writing this, I switched my X and Y. So when we put it in standard form, it's better to have your X first and then your Y. So when I simplify this, I'm going to switch the positions. So X minus 1 over 1, or anything over 1, is itself. So X minus 1 squared over 1, I can just write as X minus 1 squared plus Y minus 2 squared over 4 equals 1. There is my equation of this ellipse. Okay, the next one says write an equation of an ellipse with a major axis 8 units long and parallel to the x-axis, and minor axis 6 units long, with center at -2, 1. So let's see what I can draw. This one I can't quite draw yet. I'm going to start with my center. So I have center at -2, 1, 1, 2, 1. Okay, now I can start working in the other items. So major axis 8 units long and parallel to the x-axis. So if it's 8 units long, that means it's 4 units on either side of center. 1, 2, 3, 4. 1, 2, 3, 4. And minor axis 6 units long, which means 3 above the center, 3 below the center. 1, 2, 3. 1, 2, 3. Okay, not quite an ellipse, but it'll have to do. So now I know that A, which is once again distance from center to vertex, is 1, 2, 3, 4 units. And B is 1, 2, 3 units. So now I will write my equation out. So I have x plus 2 squared over 4 squared, which is 16, plus y minus 1 squared over 3 squared, which is 9, equals 1. Okay. Write an equation of an ellipse with a major axis 10 units long and foci at 0, 3, and 4, 3. So I'll start by plotting my foci. So they're at 0, 3, and 4, 3. So 1, 2, 3, 4, 1, 2, 3. Okay, so I know that the center of my ellipse is right in the middle of these two foci. So this one, again, you can pretty easily just look and see where it is, 1, 2 units away from each. Again, if you can't, you can always use the midpoint formula. So now I have my center. And my center is at 1, 2, 1, 2, 3. My center is at 2, 3. Okay. Now I guess I don't know my B. I don't know the distance from center to co-vertices. But I do know that A, which is distance from, or excuse me, I'm going to do C. So I know my C, which is distance from center to focus, is 2 units. Okay, so now let me find A. So my ellipse has a major axis that's 10 units long. That means, again, that it's 5 units on either side of center. So I'll start at my center, count over 5. 1, 2, 3, 4, 5. Back to center, 1, 2, 3, 4, and 5. So that means that my A distance from center to vertex is 5. So now I can find B using the formula we had for ellipses, which is C squared equals A squared minus B squared. So I have 4 equals 25 minus B squared. I'm going to subtract 25 from both sides. Then I get negative 21 equals negative B squared. 21 equals B squared. And square root of 21 equals B. And in order for me to graph it, I need a decimal approximation. So square root of 21 is approximately 4.6. So now I can plot this B, which is distance from center to co-vertex. So here's my center, 1, 2, 3, it's going to be up here. 1, 2, 3, 4.6. Sketch the ellipse. There it is. And now we just need to write the equation. So I'll start with x minus 2 squared over a squared, which is 25, plus y minus 3 squared over square root of 21 squared, which is just 21, equals 1. And now we can try to graph some of these. So for this one, number 5, I know that my center is 2, -3. So I'm just going to graph that. 1, 2, 1, 2, 3. Alright, and it looks like a equals 3, because remember the a term is always the bigger number, since the major axis is always longer. So a equals the square root of 9, 3, and b equals the square root of 4, 2. So now let me plot my points. So from the center, I'm going to go 2 units in the x direction, square root of 4. And in the y direction, I'm going to go 3 units from the center, square root of 9. 1, 2, 3. 1, 2, 3. Okay, and finally I need to plot my foci. So I'll use my equation. C squared equals a squared minus b squared. So I have c squared equals 9 minus 4. So c squared equals 5, and c equals square root of 5, which is approximately 2.2. So I will go up 2.2 and down 2.2. So my next ellipse is not in the form I want. So I'm going to have to get this into this form. And since I have an x squared term, and I have a y squared term and a y term, I know I'm going to have to complete the square. So I will start by keeping my x terms and y terms on the left side and taking my constant over to the right side. So 2x squared plus 8y squared minus 48y equals -40. Alright, next, this is just an x squared term by itself, so I can leave it as is. In order to complete the square, my a term has to have a coefficient of 1. So what I need to do is factor out that 8, just from these two terms. So I'm going to take out my 8, open up a parenthesis, and that's going to be y squared minus 6y. And then I'm going to leave myself a space, equals negative 40. So in order to do this, completing the square, I take my b term, divide it by 2, negative 6 divided by 2 equals negative 3, and then I take that number and square it. Negative 3 squared is 9. So I put a 9 here. Now on the other side, I can't just add 9, because what this number really is 9 times 8, because I pulled that 8 out. So this number is really 72, 9 times 8. So since I have 72 on this side, I've added 72 to this side, I have to do the same to the other side. So I have to do 9 times 8, 72, add it to the right side. So I have 2x squared plus 8, and then times y minus 3 squared. And then we have negative 40 plus 72, which is 32. Now, for ellipses, my equation of an ellipse has to be equal to 1. So in order to get this equal 1, I'm going to divide everything by 32. So that's going to give me x squared over 16 plus y minus 3 squared over 4 equals 1. So now this looks like the type of ellipse that we have been graphing. So it looks like my center is at 0, negative 3. So graph that point, 0. I'm sorry, I think I might have said negative 3, just 0, 3. No negative. So 0, 3. So 1, 2, 3. There's my center. And I'm going to go 4 units in the x direction. 1, 2, 3, 4. 1, 2, 3, 4. And 2 units square root of 4 in the y direction. 1, 2, 1, 2. And now I can graph. And I still need my foci. So we found that A is 4 and B is 2. So now I can find C. C squared equals A squared minus B squared, which equals 16 minus 4 equals 12. C squared equals 12. I'm going to bring this up to here and keep working. C equals square root of 12. And the square root of 12, the square root of 12 equals 2 radical 3. Now, the reason we're not doing any kind of plus minus here is because C is a distance and distances are always positive. So 2 rad 3 is about 3.5. I need that for graphing. So we'll go about 3.5 from the center. 1, 2, 3.5. 1, 2, 3.5. And this completes our notes for 10.4 part 2.